Hello students and welcome to Lesson 2. In this lesson you will learn about theoretical probability. Theoretical probability is one of the two types of probability that you were introduced to in your previous lesson. Our essential questions for today are 1. What is probability, which we have already talked about? 2. What types of probability exist, which you have been introduced to? And last, which is very new, how are theoretical probabilities calculated? So by the end of the lesson, you will learn how to actually calculate a probability. To review, let's talk about what probability is in general. In general, it is a measure of likelihood represented as a fraction, decimal, or percent. And here you can see fractions, decimals, and percents. And it's always on the continuum between never happening, which is called impossible, and always happening, which is called certain. In between we have unlikely, even, and likely probabilities. Probability is defined as between 0 and 1 if it's written as a fraction or decimal, or between 0% and 100% if written as a percent. And in the last lesson we talked about how it cannot be less than 0 and it cannot be more than 1 because it's impossible for something to happen less than never or more than always. In the previous lesson, we also talked about sample spaces. We talked about defining a sample space, which means to tell the specific possibilities. For example, if we're talking about a fair dice, then the sample space would be 1, 2, 3, 4, 5, and 6, because these are the possible things that can happen when you roll a fair dice. In today's lesson, we will need to know the size of the sample space. And telling the size of the sample space means to tell the number of possibilities in the sample space. So if you look at the sample space that we defined here, you see there are 6 possibilities. If we were talking about a coin, you would say there were 2 possibilities, heads or tails. You also learned about 2 types of probability. Theoretical probability, which is in your head probability. It's probability that you think will happen. It's looking forward to the future. Well, I think when I flip the coin, I should have a 50-50 chance of getting heads or tails. Experimental probability is the opposite. It's tested probability. It's the probability that did happen, and it's looking back towards the past. It's picking up that coin and flipping it to see what actually will happen. You may find that they match. You may find that sometimes they don't match. So our focus in this lesson is going to be on basic theoretical probability. We're going to look at what it is and how it's calculated. To calculate theoretical probability, we see this notation. All this means is the probability of some event, and we'll fill that in. It could be the probability of getting heads, the probability of getting doubles, the probability of rain. This is how you note the probability of an event. Now, we see a formula that will help us to calculate theoretical probability. It is the number of ways the outcome can occur. The number of ways that it can occur over the number in the sample space. That's why it's important for us to be able to tell the size of the sample space. Notice we have a numerator and a denominator, so this is a fraction. We know that fractions can be converted to decimals and percents, and that's why you can write probability in all 3 ways. So let's look at some examples. Let's pretend an experiment consists of rolling a fair dice. Well, if you think about the sample space of rolling a fair dice, we know that we could get a 1, we could get a 2, a 3, a 4, a 5, or a 6. There are 6 possibilities. So if we wanted to figure out what's the probability of rolling a 3, remember this notation, capital P means the probability of getting a 3. Well, think about your formula. It says, how many ways can the event happen? Look at the sample space. How many ways can a 3 happen? Only 1. This is the only number 3 on the dice. So there is only one number 3 out of, and the denominator is going to be the size of the sample space, which in this case is 6. So 1 out of 6. Now we could convert that to a decimal by division. 1 divided by 6 is 0.166, which rounds to 0.17. And we could think about that as a percent, 17%. You have a 17% chance of rolling a 3. Sometimes an event can be more than one outcome. This says probability of an odd number. So I want you to think about how many ways that event can happen. How many ways can you get an odd number on a fair dice? Well, you could get a 1, you could get a 3, or you could get a 5. So there are 3 ways to get an odd number out of 6. Now, look at this fraction, 3/6. We know that it can reduce by 3 to become 1/2. If we divide 1 by 2, we get 0.5, which we know is 0.50 or 50%. So there's a 50% chance, an even chance of getting an odd number. Now let's look at another probability. This one says, what is the probability of getting a number less than 5? Look at the sample space. How many numbers are less than 5? Well, 1 is less than 5, 2 is less than 5, 3 is less than 5, and 4 is less than 5. So how many numbers are less than 5? 4 out of 6. We know that 4 and 6 are both even numbers, so we can reduce that by 2 to get 2/3. If you divided that on the calculator, you get 0.67, which is 67%. So 67% of the numbers are less than 5. How about this one? The probability that the number is greater than 3. Take a look at the sample space. We have 1, 2, 3, 4, 5, and 6. How many numbers are greater than or equal to 3? Well, 3 is equal to 3, 4 is greater than 3, 5 is greater than 3, and 6 is greater than 3. So again, we see 4 out of 6 that are greater than or equal to 3, which reduces by 2 to get 2/3. Which if you divide it on a calculator, you would get 0.67 due to rounding, which is 67%. Let's look at another example. When playing Twister, you are permitted to spin the spinner 1 time per turn, and here's the spinner. So what is the probability of getting green? If you look at the spinner, there are 1, 2, 3, 4 green out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So there's a 4 in 16 chance, which if you reduce that by 4, you get 1/4. You have a 1/4 chance of getting green. What about the probability of left-hand red? Well, if you look at the spinner, there's only one place that's left-hand red, so it's 1 out of, and how many were there all together? 16. So the probability of getting left-hand red is 1/16. Let's look at the probability of getting yellow or blue. So we want to look and see how many events are yellow or blue. Well, here's 1, 2, 3, 4, 5, 6, 7, 8. So 8 out of, and how many were there in the sample space altogether? 16, which we know will reduce to 1/2. You have a 1/2 chance of getting blue or yellow. Now look at the next question. It says, what's the probability of getting red, yellow, blue, green, or blue? If you look, every single outcome is one of those 4 colors. So that's 16 out of 16, which is equal to 1. In yesterday's lesson, we talked about how that's a certain occurrence. This is definitely going to happen. Now, let's think of an experiment as rolling 2 fair dice. And I want us to look at what the sample space is. Now, recall the fundamental counting principle. If you want to know the total number of ways something can happen, multiply the number of options for each choice. Well, how many options are on the first dice? 6. And how many options are on the second dice? 6. So how many outcomes are there going to be altogether? 36. And that's why I created this 6x6 grid, so we can organize our outcomes. Well, we could get a 1 and a 1, a 1 and then a 2, a 1 and then a 3, a 1 and then a 4, a 1 and a 5, a 1 and a 6. We could get a 2 and then a 1, a 2 and then a 2, a 2 and then a 3, a 2 and then a 4, 2 and a 5, 2 and a 6. 3 and a 1, 3 and a 2, 3 and a 3, 3 and 4, 3 and 5, 3 and 6. 4 and 1, 4 and 2, 4 and 3, 4 and 4, 4 and 5, 4 and 6. A 5 and a 1, a 5 and a 2, a 5 and a 3, a 5 and a 4, a 5 and a 5, a 5 and a 6, a 6 and a 1, a 6 and a 2, a 6 and a 3, a 6 and a 4, a 6 and a 5, or a 6 and a 6, which if you think about it, 6 by 6 makes 36. So there are 36 possibilities. Now we're going to use this sample space to answer some questions. So what is the probability of rolling doubles? Well, I want you to look at the chart. How many places can you roll doubles? 1, 2, 3, 4, 5, 6. So the probability of doubles equals, there are 6 ways you can get doubles out of 36, which reduces to 1/6. You have a 1/6 chance of rolling doubles. How about a sum of 10? Sum means to add to 10. Well, there are 3 options that add to 10. So the probability of a sum of 10 would be 3 out of 36, which reduces to 1 out of 12. There is a 1 in 12 chance of rolling a sum of 10. What about a product of 25? Product means to multiply. There is only one set of numbers, 5 times 5, that makes a product of 25. So we get 1 out of 36. There is a 1 in 36 chance of getting a product of 25.